So let's review what we have learned so far. This is the first chapter. We learned units, physical quantities, and vectors. So I'll make a promise that I will not test your skills to convert units. So I'll give you all numbers in their standard units, base standard units such as kilograms, meters, and seconds. And for significant figures, I usually just say requires 3 sig figs for your answers. So we'll skip that. This is not the lab. And the estimates and orders of magnitude, these are interesting, but they're not easy to test. So we're down to vectors and vector addition. So vectors. We have vector additions, unit vectors, products of vectors. So first we want to do something like A and B. So A equals maybe 3, 2, 1. And B equals 2 minus 4 and 5. Okay. So let's just keep reusing A and B's for what we need. First, we need to do additions. So addition means that we can have any factor, say 2A minus half B, for instance. So this will be equal to 2 times all these factors plus negative, right? So plus negative 0.5 times all these coordinates. So that is going to be, you can multiply the factors through 6, 4, 2, plus, I like to keep a plus so I don't have to keep track of a negative. So minus 1/2 minus 1, minus 1/2 is plus 2, minus 1/2 is minus 2.5. And then you can add these together, right? Add them together and add them together. So you have a final result is 6 minus 1. So 6 minus 1, 4 plus 2, 2 minus 2.5. So you have a 5, 6 minus 0.5. Okay, so that's addition. And we also have magnitudes. So let's say magnitudes. Magnitude. So we'll just use that resultant as an example. This resultant vector 5, 6, and minus 0.5. So what is the magnitude of R? So that's equal to all its components squared. I never square negatives, so let's see, 25 plus 36 plus 0.25. You can probably skip the 0.25, it's too small. So get rid of those. Let me use a calculator. Okay, so after using my calculator, I got 7.83. So keeping 3 sig figs, that should be good enough. Okay, so that's magnitude. And we also have angle. We only have angle for 2D when we can calculate an angle of a 2D vector with the x-axis. So we'll delay that angle until we have multiplication. So dot product. So dot product is you take two vectors, you turn them into a scalar, a number. So dot product, let's do A dot B. That should be AX, BX, A by BY. These are no longer X components, Y component. They're just numbers now. AZ, BZ. So it's 3 times 2 plus 2 times negative 4 plus 1 times 5. So we have 6 minus 8 plus 5. I believe we have 3 here. Okay. So an alternative is A dot B is also equal to A's magnitude B's magnitude times cosine angle AB. And we can find A's magnitude using the same exact formula with all these components. So 3 squared plus 2 squared plus 1 squared square root. I'll leave that. I'll come back to calculate it. B's magnitude is 2 squared plus 4 squared plus 5 squared square root. So once we have AB's dot product, which is equal to 3, we're going to set the left side equal to 3. So let's get these two numbers now. Okay, using my Python calculator, I got the 321's magnitude is 3.74. And the 245 magnitude is 6.71. So now we have these. We can calculate cosine theta AB is equal to A dot B divided by A's magnitude B's magnitude. A dot B is already calculated, the 3. Divided by 3.74, 6.71. So we have a cosine value, and then if we take an inverse angle, inverse cosine, we get arc cosine, this value, and we can get a number. So let's get this number. I'll use my Python again. So 3 over 374, 671. This is 1 over 607, so maybe 0.12. Okay, so 0.120. Okay, so this is okay. I'll do an A cosine with my Python. Gives me angle 83.1 degrees. Makes sense. A small fraction means a large angle. So 83.1 degrees. That's the angle between the two vectors. So the dot product is routinely used to calculate angle between two vectors. Otherwise, it will be difficult to imagine these components. What angles are between them. So now it's let's do cross product. A cross product produces a vector. So let's do A cross B, and we define that as a C. So first we recognize that A cross B is not equal to B cross A. But they're related. There's a negative. If you swap the two operands A and B are around the cross product, you get a -1. Okay, so since the result is a vector, we can do say Cx. What is Cx is AYBZ minus AZBY. And Cy is AZBX minus AXBZ, and CZ is AXBY minus AYBX. Okay, so AYBZ, we'll be careful. AY is 2, BZ is 5, so 2, 5. AZ BY. AZ is 1, BY is minus 4. So there's a 10, there's a 4, 10 plus 4 is 14. And AZ BX, 1 and a 2. Minus AX BZ, 3 and a 5. So 2 minus 15 is minus 13. And then AX BY, 3 and minus 4. And AY BX, so 2 and a 2. 2 times 2. So this is a 12, negative 12, that's a negative 4, negative 16. So we have C, vector C is equal to 14 minus 13 minus 16. We have also this formula, the C's magnitude is equal to A's magnitude, B's magnitude, times sine angle AB. Or you can just shorten them. The magnitudes are the symbols without the dash or the harpoon head. We normally don't use this formula to calculate angle because in order to calculate angle, we need to know everything except for the sine of the angle. AB's magnitudes are easy to get. C's magnitude is not. You have to cross, you have to get all these correct, and then use this to get your magnitude. So there's a number of steps involved. But if you use A dot B on the other hand, this A dot B's magnitude is only a magnitude because it's a scalar. It's easy to calculate. And A and B's magnitude still need to be calculated anyway, so it's easier to calculate angle using a dot product instead of a cross. Although the cross product has its own applications, it's just not convenient for finding angles. So another thing that we talked about is the unit vectors. So this C vector can be expressed as a Cx vector, Cy vector, and a Cz vector. And Cx vector is 14 units long in the x direction, and the Cy is negative 13 units long in the y direction, and Cz is negative 16 units long in the z direction. Sometimes we also use IJKs. But X, Y, Z's are more easy to understand and just more obvious what they mean. Right, IJKs. So these are the unit vectors, and you can prove excuse me, you can prove the formulas, cross product and dot product using the unit vectors, and it helps you understand how dot and cross products work. So that's pretty much all for the vectors.